All right, so today we're talking about Fluxy or Flux. I don't know. I'm recording. I got that part right. There we go. All right. Sorry. Yeah, today we're talking about Flux or Flux architecture or Fluxy. Maybe. All right. So today, Fluxy, we use that word because there's not really another name for it currently. But it's characteristics that are inherited or inspired by Facebook's Flux architecture. Who's heard of Facebook's Flux architecture? Number of people. You've heard of Facebook? It's good. Good. So throughout this presentation, when I say Fluxy or Flux, I'm referring to a pattern. It's not. They have a particular implementation or a way of doing it, but there isn't a name for this that I'm aware of that really describes this class of things currently. So when I say Fluxy or Flux, I'm not actually talking about a particular implementation, but this kind of class of things. So let's talk about what is the Flux pattern. So like it says, it's more of a pattern or an architecture rather than a formal framework, right? So something you would see, this would be used instead of like an MVC type of pattern or an MV star, MVP, MVVM, or whatever flavor you want to call it. But you would use this in place of that. And hopefully it gets a name sometime so it's easier to talk about. And it's creating or has created a shift in the front-end landscape and really beyond, just this kind of this new architectural approach to web apps, and it's transferring server-side as well. And it was popularized by Facebook's Flux and React. However, it's not Facebook Flux and React specific. It could be done with many possible implementations. Some of the things in this space are like Flux, Reflux, Redux, Fluxor, React, Riot, etc. And really, you could do it with just about anything. Some tools make it pretty easy to do. Some you'd have to be really, really disciplined to stay within this pattern of doing things. Probably would be really hard to stay that disciplined. So let's talk about why a new pattern. So why not traditional MV star? This is a graph that that Facebook originally published when they came up with this pattern. And who's not familiar with MV star, C, P? Good. On this chart, arrows they represent interactions between different parts of the system, right? And in this kind of model, typically an action is invoked. It invokes some functionality within the controller, right? And based on that action, the controller potentially updates the model. And when that happens, those model changes are reflected in the view. And depending on your setup, the interaction in the view can change the model directly if you have two-way binding, or it can kick off an action that restarts this whole process, right? So this is kind of the cycle of an app, a front-end app. So let's take a look at what happens when you start scaling this. So interactions, here is an abnormally simple MVC, one action, one controller, one model, three views. You're trying to mentally map the connections between these different parts of your system, right? So the obvious weirdness of here is just the amount of arrows that have exploded, or basically the required interactions between the different parts of your system. So let's add another model and kind of see what happens there. This is still a pretty simple MVC. I can't imagine this would ever make it into a production environment. This is just pretty simple. But as you can see, as you're scaling, those interactions are increasing. And as you start approaching real-world conditions, it becomes very difficult to trace what's happening, right? Depending on the implementation, this could look very different, but the point, regardless, is the same, is that as your app scales and as you add things, the complexity scales more, probably greater than the size of your app. And let's say, okay, well, let's get rid of two-way binding and see if that kind of helps with these interactions. And as you see, I mean, it does reduce some of the arrows from here to here, right, the backwards ones, but it's still got this weird complexity thing going on where the interactions between the different parts of your system They could, if you have a problem or a bug or something, and trying to track down where it's originating from could be difficult to find. So this particular pattern, as it scales, is prone to bugs that are hard to debug, right? And on top of that, you look at that, it's really hard to kind of reason about because you have to have a real in-depth understanding of the application. And we call this, scope creep, another term, right? And just back to that banana jungle analogy where you want a banana, but instead of the banana, you got a banana and the gorilla holding the banana and the whole entire jungle. And this is kind of the situation here where you want to work on this view, or you're trying to solve a problem on this view, right? And you're trying to figure out, okay, well, there's something weird going on, or I need to add something to really fully understand that. You kind of have to understand all of these, potentially. And maybe this, maybe all of these little interactions. If we're talking about state, which is the data that's kind of being passed around, you have to know all the places where that state's being mutated and potentially how it's being mutated. So it's difficult to it's difficult to understand. It's difficult when you inherit such a project. Like if you didn't work on it, you don't have that in-depth knowledge of a project. Someone just passed this on to you. You have to go and you have to learn all of these little things, a lot of tribal or very specific knowledge that's required to even really start doing anything. In addition, it's hard to onboard new developers because they have to have very app-specific knowledge. It's difficult to maintain. It's difficult to add new features. It's difficult, probably impossible, really, to test, etc. It's just difficult. Any comments or questions or anything about that? Disagreements, statements? Okay. Heartbeats. All right, so let's talk about how Flux is different. So one of the major characteristics of Flux is this idea of unidirectional data flow. Sometimes you hear in this type of architecture, this type of pattern, data flows down. So let's take a look at what that means exactly, right? So on this graphic here, I'm showing on the left an object that kind of represents the model. The curly brackets represent like an object, and then you have this antenna, this broadcast coming out of it, right? And on the right is a thing kind of representing a view. It's very much, it's kind of like model view, but in this kind of architecture, it's not called a model. They call it a store, and the reasons why are because it's more than the model, honestly. It contains the model. You can't really change the model directly, so we'll explain exactly what that means later. It allows subscribers, right? So you hook up to one of these stores anytime the model changes, you get a notification that there was a change. It notifies those listeners anytime one of those changes to state occur. And this thing that kind of looks like a view, but not quite a complete view, it subscribes to the store. All it does is it reacts to the store state, right? That's where the name React came from. So what that means is itself is stateless. So it doesn't you don't keep track of anything about your app inside of your view whatsoever. Everything it needs is brought in. It's stateless. It's a pure function. It can't change itself directly, meaning you don't imperatively go about changing class names or content or anything within your view. You basically operate as data in, data out. That's it. So it's what they call a pure function of state. And what that means is you pass in a particular data structure. Every single time you pass in that same data structure, you're going to get the same thing out. And that will be true of everything. It's like in algebra where they talked about the vertical line test, where a function is only valid if you only cross that once. It's the same thing here. So no matter what, a particular set of input will always produce the exact same output. And what that does is that prevents scope creep. You don't have to kind of trace back. The problem from the last slide is figuring out what's causing the change, right? Well, here, everything it needs is passed in. It has no dependencies of anything greater than itself. So everything it needs is passed in. You don't have to worry about tracing things back because everything is given to it. So looking at this, this really isn't the complete view. This is called some people call it a smart component, right? And it's part of the view. In addition to the view, you have these dumb components, okay? And how these two things different is a dumb component is 100% decoupled from the store, from the smart component, and really from each other. It has no tie whatsoever to anything. There are some caveats there, like a dumb component could be a composition of other dumb components, but conceptually, it's just a complete detachment from your app, from everything, really. And it also, too, is pure and reactive. So it only changes based upon what's passed in. It can't change itself. The only way you can change how that particular dumb component looks like is to pass in different information. That's it. Which makes these things extremely reusable and composable. Because, like I said, every dependency is injected in via a property. Okay. So what the smart component does is it composes these dumb components, right? And sometimes, depending on the implementation or the person, these are also sometimes called controller views. You don't like that name? No. But then it's called smart components always. And pretty much your smart components and your dumb components, that make up your view layer. And the entire view layer is completely reactive to the store. So if you want to change the way your view looks, you have to actually change the information in the store. There's no other way to change the way the rendered output there's asterisk. Generally speaking, there is no way to change the visual output it produces without changing the data in the store. Does that make sense? Questions, comments about that? So here we're gonna look at a dumb component, and this is written in JSX, which another Facebook thing, but not React specific. There are other things that use JSX as well. If you look at this dumb component, let's talk about what dependencies are here. Anyone? No dependencies. Hey, no. Good job. Nothing about React, right? Nothing about Riot, nothing about Angular, nothing about, this is just JavaScript plus an extension to the syntax, the JSX. So your dependency here is a build environment that converts JSX. All JSX does is it converts that looking thing, weird, it's kind of gross, it feels gross. But it converts that to an object. All that is a different object literal syntax. Okay. So there's nothing specific about this whatsoever. And to kind of show that, here we're showing one of those dumb components, right? We're defining this. This is just a function. That's all it is. It's a function. It accepts an object. That object has one key called people. That people key should be an array of people, right? We're mapping over those list of people, and we're converting that list of people into essentially a bunch of objects, right? And then down here, we're returning if people.length, right? So basically, if the array wasn't empty, we're returning what essentially will eventually end up being an unordered list. Or if there were no people, it'll say this, right? And down here we have this model, right? This is simulating data coming in from the store. And this is basically down here, you can see people is being fed in here. So we're using this dumb component called people list. We're passing in this array of people. And can you see this over here? right? And based on the output, we're getting just kind of what we expect. So if we kind of tinker with this, all we do is tinker with this data. Oops. What happened?
Lost your first. Yeah. Lost your first curly.
Ah. Thank you. Anyway, this kind of gets the gist, right? You want to change the rendered output. This includes classes that are assigned to your object structure. This includes anything. If you want to change the rendered output, in order to do so, you have to change the data coming in. So your view completely reacts to the data coming in.
Would you mind scrolling down a little further? Okay. What is that silliness?
This right here?
Yeah.
So this is emulating the smart component.
Business.
This is emulating that smart component,
All
right? And but all this is doing is making the change to the DOM. So this is, you wouldn't typically find this type of stuff in your DOM components, right? You would really only find like this right here.
Sure.
That's your DOM component. It's just a function. A function that accepts an object, returns an object, right? Nothing vendor specific really about that. Any other questions or comments?
Oh, wait,
What's up?
can you show the HTML?
Here?
Yeah. It just has data attributes to represent the smart component stuff.
So yeah, the rendered DOM, which actually is the rendered DOM output, compiled DOM if you want to think about it that way. It has React-specific identifiers to help keep things in track. I think you can modify that, the way that looks, but typically in this type of workflow, that working with the DOM directly, you don't. It's pretty much abstracted from you. There are some caveats to that. If you need state, for instance, then there may be some DOM interactions you need to do. For the most part, you don't ever really directly interact with the DOM. There's an abstraction there. A lot of the DOM principles are carried over. Dealing with event like DOM events and things like that, you would still use like e.target and all those type of things. But you don't really ever you don't navigate or traverse the DOM. There's no imperative operations in that way.
Is this what is meant by virtual DOM?
Sort of, yeah. So you're constructing a virtual DOM in React and various other view layer implementations. They have an idea of a virtual DOM. Not all of them do, but essentially what you do is you're constructing a DOM that is smart, a DOM structure that is smart, and there's some diffing going on. It has a representation of the DOM, and then when that changes, it actually only updates the part of the actual DOM that needs to update. So which, yeah, makes it really, really performant. Any other questions or comments? All right. So does this make sense for the most part? It's not complex. We okay? Does it not make sense? So okay, then I'll test you then. Pop quiz. So in this model, right, here we have our store. Here we have our, all right, and here, all right, and if I wanted to change the rendered UI of this, I wanted to change maybe a class, maybe what's there, how do I do that? Yay, change the state in the store, right? That's how you make changes. So how do you change the state in the store? So step 2, store versus a model, right? We'll kind of explain this a little bit better. So a store, it contains the model. It's not the model, it contains the model, right? And that model really is a plain old JavaScript object. There's nothing super special about that. It's just an object. It's the single source of truth in your app. It's the only place in an app where you would keep state. It's not spread across your components. It's not anywhere else. It's managed here in your store. in addition to containing the model, it contains the logic to change its state, right? So what you do is when you create something like this, you create a predefined list of all possible mutations. And these are either called action handlers, sometimes they're called reducers. Throughout this presentation, I'll just call them action handlers, right? And basically you say, okay, here's my state, and here's how you change it. And in order to change the state, it has to match something that you've already created. So there's only one way to ever change the information in your store, your state, and you have to actually create some rule that does that. It may kind of feel like a restriction, but it's actually really, really empowering because it's super easy to scale and maintain. Hopefully that'll show here in a minute. So in addition to containing the logic to change its state, it also listens for and then reacts to dispatched actions, right? So in order to actually trigger one of those action handlers, you have to dispatch an action into it, right? And that means there's no traditional getters or setters. Change requests are broadcasted in, and it's the only way you can change the information in the store is through one of these methods. And then if a change occurs, then we've already demonstrated it emits or it broadcasts, hey, I changed to anything that's listening to it. Questions or comments? So if we take a look at our drawing from before, it's kind of incomplete, right? You have the model or the state, the actual object in there. You have this notifier thing that notifies anything listening, hey, I've changed, right? You have these things called action handlers. They're a list of instructions, essentially predefined, a predefined list of mutations. And then you have this nice animated GIF, a listener. That's basically it's listening for actions coming in. If action comes in, it checks against the action handlers and says, hey, is this a valid action? If it's a valid action, the action handler acts on that particular action, which could or could not result in changing the state. And if that changes, then it notifies anything else listening that, hey, I was changed, right? So what is the input output of this? I mean, what are you seeing as far as how do you interface with this? So basically the ends, right? You're in and out. It's all event-based, right? And so when it's event-based, it makes it extremely decoupled from everything because its dependencies are broadcasted in and it broadcasts out. It doesn't care what's connected to it. Just something has to be able to broadcast in and something needs to be able to listen to it when it broadcasts out. So it's extremely decoupled from the rest of your app. And when you're creating something in this type of pattern or architecture, the only thing you ever write as regards to the store, you don't really ever worry about the listener and about really even the model or the state or even the notifiers. What you write are action handlers. That's pretty much it. So don't let the complexity of this graphic send the wrong idea. It's not complex. You write action handlers. So to really understand action handlers, let's talk about what an action is, right? The thing being broadcasted in. Again, it's just a plain old JavaScript object. There's one requirement on that object. It has to have a type key that names the mutation that it wants, right? Like add person, remove person, whatever the case may be. You have to give that mutation a name, and you do so with that object structure of type equals to that name. And that name needs to be unique across your app, or else there could be collisions. It's not really a problem. It's very easy to overcome. The rest of that action object coming in, that structure is completely up to you. You can have it be whatever you want, although they do recommend just be as minimalist as possible. If you need to remove something from the store, don't pass in the whole object. Just pass in the ID, for instance, and derive the rest in your store. That way, it keeps the load smaller. So down here's an example of one of those actions coming in. It's object. The type is add person, has a name, a location, and food. This is arbitrary. It could be really anything. You can define it to be whatever you want. But again, just a plain old JavaScript object. Here's an example. Yeah. Question? No.
So far you've shown us only actions that change data, but would this be also true for actions which only like decorate the UI, like adding an error class around a form or
So typically,
highlighting an image or something like that?
so what you would do is your view would react to something in the data. So in your data, you'd have to say, hey, there's an error,
Yeah.
right? So you would change the model inside of your store to represent some sort of error. And then based on that flows on down, and then your view reacts to that. Your view knows, hey, one of the things I can receive is some sort of indication that there was an error, and now I'm going to react to that.
So anytime you want anything to look any differently on the client, you have to change the data.
Yeah, that's mostly true. There are.
That's
Mhm.
what you've been saying all along, I guess.
Yeah, there are some kind of exceptions. Like you can create stateful components, but you want to avoid them if you can. And the state doesn't persist. It's really temporary. It would be equivalent to like the same type of state you could potentially represent in CSS, like on hover
Sure.
or kind of thing, right? And so it's not really application state. It's temporary, not really stored. It shouldn't really be called state. I don't even know what you'd call it, but.
And when we talk about modifying the data or modifying the store, is that persisted to a database, or are you just talking only on the client side in memory you're modifying?
That's completely up to you, and I'll show you a little later on that pattern if that's what you want to do. So you can update all of it or parts of it, or you can keep it in sync on the server. It can be completely client, but there in this flow of things, there is a place where you would put that if you wanted that to happen. Anything else? Those are good questions. All right, so here is another example of an action. Really, really simple. One key, type. And this is kind of the default demo that you'd see if you went to any Flux implementation, right? Increment counter. That's it. It has no other information whatsoever. And right over on the right, this is what looks like this. In this case, this is a reducer. This is a Redux kind of way of doing it. They're all very, very similar. But all it is a function that expects a state. Yeah, switch cases, I know. You don't have to use a switch case. But I think you'll find as you go on, it makes it a lot more readable, legible, and easier to understand. Anyway, so you have a function on the right? It expects a state coming in and an action. And you kind of give it a default state when you bootstrap. In this case, we're saying, hey, the default state is 0. And all we're doing is we're switching the action.type, right? We're saying, hey, if the thing coming in is increment counter, I'm going to return, in this case, we're returning a whole new state every single time. That's kind of a Redux way of doing it. It returns state plus 1. If it receives decrement counter, it returns state minus 1, and the default is just to return the current state. So if I try to broadcast something in that didn't match, it would have no effect on your store whatsoever. So cool thing about this is your actions coming in, it just asks the store to make the mutation and hangs up, right? It doesn't care if it's invalid or anything. It's blissfully ignorant of the current state, how the mutation occurs, or even if it occurs. All it's simply doing is just asking, and that's it. There's no consistency whatsoever. So that also provides a lot of decoupling. So again, it's usually a switch statement, and that can feel gross to some people. It's not the only way you can do it, but basically, an action is coming in. You need to figure out, hey, what's the type? You can be creative on how you do that. Some people like to create a map, an object map or something like that basically looks to see if that exists. And if it does, it executes. There's a number of ways of doing it, but the point is you need to look at action.type. You have a very finite set of things that can come in. You're checking for those specific things. And if it matches, you do something. If it doesn't, you don't. Make sense? Question?
Well, so it seems like that is basically 2 action handlers in one. One for the action of increment counter and one for the action of decrement counter.
Yeah.
Is that understanding?
They would call this whole thing, depending on the implementation, they would call that whole function a reducer. It's basically you're kind of operating on the same part of the state, right? So, right here, as your app scales, your state is actually going to be a tree, and you're going to be operating on branches of the tree. And so this is saying, hey, there's a particular branch of this tree that's representing a counter, right? And so these are all the actions that can really affect that branch of the tree, if you want to look at it that way. Do you have a comment?
Yeah, so the idea is you have an action like you said, an action handler. You subdivide your state tree into different parts, and action handlers are very isolated to a particular part of the state. So this counter could be a part of a larger state tree, but anything that has to do with that counter, whatever action having to do with that, you could have a clear counter or a set counter to, something, whatever. But since it all operates on the counter, you have it contained in one action handler.
Do I have to?
No.
Cool.
I guess the other thing that was occurring to me is just because you have a switch statement there and a case statement that's adding one to the state doesn't necessarily mean the implementation has to look like
Right.
Be an abstraction within there.
Right.
That more
So
cleanly handles the complex logic.
yeah, it really shouldn't. The complexity shouldn't be in here. Honestly, this is always going to be pretty simple. This is just going to be. You think about it, this really is just a kind of a transform layer, right? But yes, to Brian's point, it's just a function. First argument is state. Second argument is action. It needs to return a new state. That's pretty much the API of that function, right? That's the signature. You need to pass in a state, pass in an action. It returns a new state.
Super easy to test. And how is that JavaScript object mapped to that particular function? How is it passed in as the second parameter of that function?
So that's all managed inside of the particular implementation you're doing. So you could think there's a container around this that basically would do that. You don't ever really have to worry about any of that unless you wanted to write one from scratch, essentially. But essentially, you end up composing a list of these reducers, and from that you kind of create a default state tree, right? And then from that, things coming in, you know kind of where that should be, kind of the internal workings. Again, these are things you would never have to do. The internal workings knows where to map that to which part of the tree. If that makes sense. So the only thing you have to worry about is making sure that this and this are matching, right? And that there's no collisions, no name
Which
collisions.
typically you would have referencing the same object instead of doing a string match right here.
It would be there's different strategies for this, like constants that they both import in. And there's different ways of ensuring that kind of thing. But at the end of the day, it really is a matter of does these things match? And if they match, perform this. Because really, any broadcast coming in is going to look for this particular action and send it along, right? If it matches, then it performs. If not, it doesn't. Any other questions? So it checks for the matching action.type. It optionally performs the mutation, which we talked about here. And here's an example store, and this is in Redux, which I think is awesome. So all we're doing, the API for Redux is super, super simple, right? You're importing this method from Redux called createStore. Here we have that same reducer or action handler right here, right? You're creating a store, and then you're subscribing. And we kind of play around a little bit with that.
Jerry, can you help me out? Who is the event publisher? That's right. My brain's not letting me answer that question. Who's publishing the event?
Which end, in or out?
Well, I've subscribed here, so the store is subscribed to some event. Who is the event generator? I think you covered it.
It's part of the store that you use. So in this case, Redux.
No, the event generator. There's a concept called an event creator.
So events come in and events come out. So I don't know which one you're talking
Or
about.
action creator.
Hey.
Action
It's
creator.
good. Yeah.
Okay, all right, sorry.
Well, yeah. All right. Okay. So here is an implementation of this particular store in JSBin, right? I can't use imports here, so I have to kind of fake it, right? The same idea, I have a function that accepts a state and an action object, and we're going to switch over that, and depending on the action, we're going to return a state. It's either going to be the current one if nothing changed or a new one. Down here, we're going to create the store out of this function, this to-dos, and then we're going to subscribe, right? And so if I come over here, and so you see right here how we've subscribed to the state. So anytime it changes, I'm going to get notified, and then based on that notification, I'm going to get the state and I'm going to log it out. So based on that, so this one right here, this is now the current status of the state. This is just what was returned from that particular function. This is basically the same thing I just typed in, right? So if I do that again, but I'm going to add a second one, so now here's my state object. So if I just want to call randomly store.getState, that's currently what's in my object. All I've done is broadcasted, right? I'm just broadcasting in an object telling it what to do. And so in this case, we've added a couple of to-dos. I'll add a third one. And we do by, again, just dispatching that action, right? So we've dispatched this action in, and now if we go up and take a look at our store, the state of our store has, in this particular tree, has three objects right now. Your first, your second, and your third. And you can look on the add to do. I give a task, and I'm basically giving each item comes in. I'm just generating an ID based on the count, right? This is not what you would normally do. I'm just kind of faking it. But now there is that other action attached to this particular state or store, and that's removing. And so we see, the thing that was sent was a remove and one, and now my store represents that, right? So if I do the state of the store, now I only have two things with ID 2 and 3. You kind of get ID collisions if I went on here, but anyway, this is just to demonstrate how it works. You pass in an action, the action changes the state in the store. When the state in the store changes, it sends out notifications. Anything subscribing to that simply reacts. Just reacts to the new state. So pretty much your view layer should always operate in a completely stateless way. It just expects data in and reacts to the data coming in. Any questions or comments about this particular part? Oh, I got 10 minutes. Okay, I'm going to go a little faster then. So a third attribute on how it's different is this concept that actions float up. We talked about unidirectional data flow, where data flows down. Now you have this concept of action floats up, right? So here's kind of the full chart, fullish chart that we talked about so far, right? We talked about the store. You have that listener. It's waiting for actions to be broadcasted in. We have the handlers. It handles any of those actions. Based on that, you're going to update the state in the store. If that happens, you're going to notify anything listening. The things listening are going to react to the new state, right? We're good here? Questions, comments? So what's missing? Brian?
We need an event.
Thank you. All right, you need a way to actually pass in those actions, right? So here you have this idea of action creators, these little helpers that just pass in or dispatch or broadcast those objects, right? And so you have the action creator. It's just it's a function that returns an object, an action object. It abstracts away the details of the action object structure. So the rest of your app doesn't need to know the details of your store whatsoever. It pretty much just executes the function, and based on that it creates that new the action object and passes it along. So it doesn't need to know about that. In this particular area, this is where you typically find async code or code that would talk to a server, and if you're synchronizing state across client server, you typically find it in this layer, the action creator layer. This is kind of like the upstream glue between the store and the smart components, if you want to look at it that way. So here's an example of an action creator. Very simple, right? There's no framework specific stuff here. It's just a function that accepts text and returns an object. I mean, there's nothing super special about that, right? Here's an example of part of a smart component where we're importing the dispatch functionality from the store. We're importing that add to do action creator that we just defined on the left. And we're importing this fake dumb component called dumb from components dumb.js, right? We are, if you look here, all we're doing here is pre-binding the action creator with the dispatch. So whenever add is executed with text, it's just going to automatically dispatch to the store. So here we're hooking up the store to the dumb component to the action. We're gluing all the stuff together. And down here you can see, hey, we want an instance of this dumb component, and the action it's expecting some add action, a function to execute. Here's the function you execute when you need to. So you're passing in what to do, the events. So these dumb components are just completely decoupled from your app. They don't, yeah.
So the text add action, that's how it maps to that JavaScript function.
So
like your function had your switch statement in there.
So add right here. This add to do maps to the switch statement.
Yeah.
So what this does is it takes that object creation, and anytime you execute it, not only does it create that action object, it emits it. And now we're kind of passing that emitter, that bound emitter type of thing, down into your dumb component. And now your dumb component just knows, hey, when some particular thing happens, when the user does something particular, I need to execute this function that was passed down to me. So it's completely decoupled, right? Cross apps, yeah.
Why is the dumb component attribute called add action? Is that dictated or is that defined?
That's just what the dumb component chose to use. Yeah. So the smart component kind of has this idea that of the signature of the dumb component, if you will, and is simply reacting to that. So you can name whatever you want. Any other questions, comments? I have like 5 minutes, so I'm going to go faster. All right, so how is Flux different? The distinct composable parts, and we've kind of talked about that. So we're going to have a quick poll. Who believes, based on this graphic and things we talked about, I know it's kind of a lot of parts to talk about, that you kind of have a decent understanding of this whole system? Out of those that raised your hands, who's actually studied this before? So there's some people that just kind of grasped it based on just this. Yes, is that accurate? So who's ready to just start writing a Flux app now if a project starter was provided? Okay. Who feels like they understand parts of it, but they're still making the connections? All right, who's completely lost? Come on, don't be ashamed. So the part that's awesome is it doesn't matter how much of it right now you currently understand. So it's so segmented that you don't have to understand the whole thing. We can set you to work right now on one part. Right? All we have to do is say, hey, here are some rules you need to follow. That's it. You don't have to understand the whole system. You don't have to understand the whole app. Right? So basically, of this system, here are the things that you author. Action creators, action handlers, smart components, dumb components. This is a little simplification, but generally true. Right? So let's look at action handlers and dumb components. They're blissfully ignorant of any other part of the whole system. Right? In fact, it'd be better for you not to know the rest of the system because then you're not going to start coupling things where they shouldn't be coupled. Right? They're pure. They have no library dependencies. You just write, hey, I want you to create me a function that accepts a store and an action and returns a store. It has nothing. I mean, you don't need to know anything else besides that. Same with the dumb components. Hey, create a component. It's going to expect, here generally what it needs to do. Provide a sensible API. You don't have to have any knowledge whatsoever of the rest of the system. And really, like I said, I think it's preferable probably not to have knowledge of the rest of the app. That way you're not coupling things that shouldn't be coupled. And so this makes these parts really application agnostic. You can move them across applications. They're completely shareable. They're not tied to anything. So let's look at the action creator. Again, there's no coupling here. All it did, it's a function that sends out an object, right? So it does have to be aware of other parts of the system to a degree. It needs to know the action object structure. That's cohesion. It's not coupling. You could swap that out with something else and have pretty much no effect whatsoever, right? It's generally a little more app specific, but there is reuse across apps here as well. So if there is a, apps share similar ideas or similar problem spaces they need to solve, like managing lists or search results or anything like that whatsoever, you can you can move those across applications. So they also export their functionality. So it does require some awareness of other parts of the system, but not the whole system. And then your smart component or your controller view, depending on what you want to call it, right? This is really kind of the glue. It imports the store, it imports the DOM components, it imports the actions, it subscribes to the store, it disperses data and actions to the DOM components. That's its role, right? And it kind of is app specific. You may get some reusability here depending on what you're doing, but it's pretty app specific. But essentially, it's just a smart composition, right? You can create as many of these as you want. Everything is distinct. Every part of this architecture, this pattern is a distinct unit. And each unit is reusable, repeatable, extensible, composable, all the buzzwords. Pure, encapsulated, swappable, and testable. Every part is testable, which is awesome.
Not just lip service.
Right.
Yes. Thank you.
What was that? Sorry. So let's talk about how it scales, right? So here's that same architecture. We're starting with 2 action creators, an action handler, 1 smart component, and 3 dumb components. So let's add some dumb components. So our app is getting bigger, but did the complexity change? No, it's just more of something, right? We want to add smart components. It's just the complexity is not changing. It's the same complexity. Add some action handlers. So doing so, it's probably going to result in some more action creators. But really, the complexity is still the same, right? You're not as your app grows, the complexity isn't growing with it. Does that make sense? Any questions, comments? So as your app grows bigger, complexity doesn't. Perfect timing. So here's just some other visual representations of this architecture. So now if you come across these, they should make sense, right? Store, view, action, dispatch. Data flows down, actions float up, right? Same idea. You can think of it as a cycle. This is Facebook's graphic. This is kind of redundant. It's just to show you that, hey, your app bootstraps by an action. Once that happens, you just follow this pattern the whole entire time. This one takes the idea of data flowing down very literal, right? So data's flowing down, action's flowing up. But same idea. I mean, these are different names for things potentially, but the responsibilities are the same. So Jasper, this probably does a good job of explaining where the web service part hooks in, right? So your app is initiated or bootstrapped by some action. That action could result in a call to an API. It could not. It just depends. Anyway, it comes down. And based on that, an action could actually return, you can be in this loop here if you wanted to, I guess. But essentially that's how server-side communication fits in. So you can store the whole state, parts of the state. That's all that logic will be mapped inside of an action. Here's just kind of a really verbose version of the same thing. The only difference is different naming. We added dumb components. We added a user interaction that's really describing how actions are occurring, and then an API. And then we have like 1 minute, but I have just a little bit of a full simulated app here. So here we have this simple reducer, right? This should look familiar. Just a function, accepts a state, an action, returns a new state. We've created some action creators. We're going to have, based on this, all we're doing is kind of creating an easy way to interact with this, right? Hey, you invoke me. I'm gonna create the type of object that this store particularly expects, right? So we're creating the store. Here's our dumb component, right? We're calling this one counter. All it wants is a value, the current value from the state. It wants to know how to increment. And it wants to know how to decrement. That's it. You pass in the functions that tell it how to do all that stuff, completely decoupled from anything but that. And it's saying, hey, when this button is clicked, I'm going to invoke the function you called. And when this one is clicked, I'm going to invoke the decrement function that you provided me. Everything it needs is provided, right? And so and then in a smart component, this is where there's going to be a little more complexity as you kind of glue all these things together. Not super complex, though. Typically, you have your import statements here, but we're on JSPin. So this is a small, really simple optional library that just makes hooking things up easier, right? You don't have to use it. But it just allows me to create this kind of container around everything. I'm creating a container around a DOM component, around the actions, and around the store. I want to think of it that way. And hey, here's how you compose. All this is doing is composing these things together, right? We're saying, hey, the state you need should look like this. This is mapping to what our DOM component needs, right? It needs a value key. Here are the actions. We're just going to pre-bind them to a dispatch functionality, but essentially the same actions from above. So we know that this particular composition will have an attachment, an on increment and on decrement, basically the things our DOM component will need. It's pre-bound, a pre-bound function that when executed dispatches to our store, which is passed in down here. So this could connect to any store whatsoever, and it's not coupled to a particular store, but in this case we're just doing it to the one that we created up here somewhere, right here. Questions, comments? And over here as we interact with it, and there is a working app. Super useful for keeping score of one person. Questions, comments about that?
Question.
Yeah.
So say you want to use this but not use JSX.
Mm-hmm.
Is that possible?
So there are other things besides React that so it depends. You don't have, I mean, you can use, the nice thing, React is completely decoupled from the architecture, and any Redux implement or any JSX implementation should be as well. So JSX isn't tied to this architecture, it is not tied to React. So you just have to find some JSX support for whatever platform you're trying to go in.
But if you've never used JSX, give it a shot.
Yeah.
It looks very ugly, but once you start using it, you won't want to go back to write
Right.
HTML.
Other than the HTML being embedded in it, how does it compare to, say, ECMAScript 6?
So you could think of it as an extension to ES6. It's not a standard. So JSX is not standard. You can think of it as just a syntax extension. So basically everything you would write would be, you'd write ES6 plus this syntax extension. And where all JSX is doing is just another way of constructing an object. If you want to think, in a familiar way to people who have done web development, right? Yeah.
Can you go back to your code?
Uh-huh.
In your HTML and the JSX, you declare on-click handlers,
Mm-hmm.
and that seems like the way we all learned when we were in our high school web development.
Feels
classes.
gross, right?
Yeah, is that a function of having? I mean, your HTML now is in your JavaScript, because if you did it the modern way of declaring an event handler, you'd have to like find that thing by traversing the DOM, right?
Right.
But if you don't traverse the DOM,
So
is this now the best practice for assigning event handlers?
So you're
How would you assign more than one event handler?
yeah, what you're sniffing out is that gross reaction to JSX. And everyone kind of has this like JSX shock, especially if you've done web development for a while, because it kind of feels like you're violating rules that we've learned are bad, that lead to bad things. But I think if you take some time and you question why at some point in time did this become a best practice to do it this way? What problems did they solve by doing that? And you ask those questions, and then you compare that into JSX or this particular syntax, and see if those problems that this thing solved actually still exist here. And you'll find that they don't. So I know everyone kind of has this like, was it called conditioned taste aversion, right? Where something like that, where it feels like your reaction is it's gross because you've been conditioned to recognize it's gross because in the past something like this led to a lot of problems. And so one of the solutions to those problems was to do the separation of concerns, where really it was a separation of technology, right? If you look into it and figure out and you kind of really think about what this separation actually solved for you, I think you'll find that JSX actually handles it much more elegantly.
I should say Jared's not a fanboy of this. You should have seen his initial reaction. It was pretty.
It took me
It was
months.
vitriolic.
Like it took me months to even like take this seriously because of how like that gross reaction it had. But I kind of swallowed my natural reaction, and a lot of people I respected were really talking about how awesome it is. That hey, it's good for you. Just take that step kind of thing. And it took me a long time to take that step. But when I did, I agree.
So you want to throw a second counter on screen. What can you end up reusing?
So this entire component, honestly. So you basically, what you would do is you compose two of these exact same component. So in your smart component, you would import this thing and you would just instantiate it twice. You just have to the thing is you'd have to hook it up to different parts of your store. So your model coming in, right, your store would need to support two different counters.
Show me where that would be in your example. At the create store, is that?
So I would have to, so right now I have a flat store. Right, I have one thing. So this is really abnormally simple.
Right.
So typically the state in your store is a tree. So I'd actually have to create a tree, right? So Redux handles this really elegantly. You actually still manage them separately, but you end up composing them all together. It's just like, I think it's called combine reducers is the name of the method off of it, and you just pass in the two different functions, right? So now you have two different parts of your tree, different names that would come down and map into here. So down here, it creates that twice, so that I'll write something, I'll put on Slack. How about that? I don't want to live code.
Also, the next Donuts with Family Search, we're going to be building a React app from start to finish, live coding. So pray for me. But we'll show something like that.
It's not super. I can have something probably
I'm
today.
just trying to wrap my head around what. I mean, if the idea was we had a lot of interdependencies and we're trying to simplify that.
Yeah.
But the example that we're showing is a really simple example.
It is.
So I'm not seeing the interdependencies. I'm trying
Right.
to get a view in my head of, what does this save me from?
Yeah, I'm afraid if I did that off the bat, it would unnecessarily confuse what we're trying to show.
Understood.
Yeah. So, but I'll put something together. It wouldn't take very long. Just combining that, and I'll put it on Slack. Any other questions, comments? I think I'm done. Let's see. I am.
Thanks for staying, guys. This is new stuff. If anyone's concerned about it and didn't want to say anything,